Very good. Today, you're going to learn how to calculate probabilities by conducting experiments. And the reason why we're conducting experiments is for some things, it's not practical to do a real life an experiment. So we're going to do simulations for our experiment. For example, we're going to be using colored chips. We're going to be using dice. We're even going to bring in a spinner, and you're going to be getting to use these materials to complete a task or an activity worksheet with a partner. So listen for instructions on what we do and what we need to learn to be able to conduct our experiment. So when I was a kid, we would go down the cereal aisle in the grocery store, and they'd put on the cereal boxes, hey, 1 in 3 boxes has a free movie ticket inside the box. And so it was a business tactic to get parents to buy a bunch of boxes because the kids were begging, oh, Mom, I want to get the prize. We had like tattoos or like little toy games and stuff. You'd roll a little marble around. So the cereal company claims 1 in 3. If you decide to purchase this cereal, what is the probability it contains a movie ticket? Well, out of 3 boxes that I buy, 1 of them has a winning ticket. So I would say the probability of a win would be 1 out of 3 boxes. Well, does that mean if I buy 3 boxes at the store, am I guaranteed to have a prize in one of those boxes? Nod yes or no. What do you think? So I just got 3 boxes of Wheaties. Am I guaranteed? You guys are correct. It's not a guarantee. Maybe if I bought 6 boxes, they said I should, 2 of those boxes out of the 6 should have a prize, right? If I bought 99 boxes, I should have 33 boxes with a prize. That's what they claim. But that might not be exactly the results if I actually did that. And it's not practical for me to buy 99 boxes of cereal. I don't have a place to store them. And my kids, I'm sure after the 5th box, they'd get sick of it. I have like Cinnamon Toast Crunch, which we all love. I bought it on a sale, and it's still sitting in my pantry, right? Sometimes too much is not that good. So we're going to simulate this experiment. So let me talk about how to simulate. So if I know I want 1 out of 3 things to win, one thing I could do is use some colored pieces where I say, hey, 1 out of 3 objects is a winner. So I'm going to call the blue the winner, and the greens would be a box of cereal with no prize in it. I'm going to take these, I'm going to raise my camera up a little bit. I'm going to take these colors, put them in a cup so it's random, and I'm going to say that I'm shopping at the store, I'm reaching in, and I am going to buy a box off the shelf. And we're going to find out if the box off the shelf has a prize in it. Let's see what I got. Blue. If you remember, blue was the winning one, so I actually got a prize that time. We're going to replace it. So again, my probability is still even. And this time I got a green. So that was buying a box of cereal without a prize. So I lost that one. Let's do one more. And again, I got a box of cereal that did not have a prize in it. So I actually, just by luck, out of my 3 purchases of cereal, because I drew 3 times, 1 of them did have a prize. I had one time where I got the blue marble. So that's kind of a way to simulate. So here's my question to you. If I had a dice, because I didn't have any colored marble, how could I use the dice to run an experiment? So like I rolled a 6, like how could I use the numbers to help me simulate winning a prize or not winning a prize? What do you think, Abby? Say it really loud.
2 of the numbers could be winning a prize, and the other 4 could be not winning one.
Okay, love it. Which numbers do you want to have be the winners?
1 and 6.
1 and 6 or 5 and 6?
1 and 6.
1 and 6. Okay, I like it. So this would be a win and a win, and this would be a loss, 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 loss. So you're saying there's 2 wins out of 6 numbers. That reduces to 1/3. So she thought, oh, hey, I could use a 6-sided thing. So let's try that real quick. I roll a dice. I got a 4. That's a loss. I got a 3. That's a loss, and a 4. So on that one, just by luck, by randomness, by unluck, all 3 purchases of cereal did not have a prize. So I'd have to conduct more trials to try to get the experiment to match what the theory says. So here's another question. I've got a bin full of spinners. I have 3-sided spinners, 4-sided spinners, 5-sided spinners, and I have 6-sided spinners. How could we do this kind of a similar thing on a spinner? What if we picked her same number? She said, let's use 1 and 6 as the winners. So here's my 2 winners. Does it matter that they're touching? Not really, because when I spin it, it should be kind of random. So that would be not 1. Didn't get a prize, the 2. And, oh, I did get a prize. Luckily, it landed on a 1. So I say, hey, 1 out of my 3 spins, 1 out of my 3 boxes of cereals, I really did get a prize. Okay, so now that I've explained that, and there's different ways to do it, we are going to do this as a class really quick before I set you with partners to do it. So Mrs. Koffel's going to have a cup. She's going to walk around the class, and you guys are going to reach your hand inside and pull a color out. And I'm going to record the results on the table, and this would simulate that first one that I did where I got a win and then 2 losses. Was there at least 1 winner in my 3 boxes of cereal purchase? Yes. So she'll walk around and go ahead and just say out loud, really loud, if it's a loss or a win.
Win.
Okay.
Loss.
Okay.
Loss.
Loss. So did we have at least 1? Yes, we did. Put a yes right there.
Loss.
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 Oh, crazy. So just by chance, we bought 3 boxes of cereal and none of them had a prize.
Win.
A win. So here's our 4th trial. We already got a prize.
Loss.
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 Loss. But we just needed one win to have at least 1 out of 3. So yes.
Win.
Win.
Loss.
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 And a loss. Okay. Awesome. So you guys got to do a little fun participation there. So we say yes. Okay. This is our next part. It says to compute the experimental probability. So in other words, that's probability of having a win in a purchase of 3 boxes of cereal. It says add the number of successes, or so yeses, in the last column. So 1, 2, 3, 4. We had 4. And then divide that by the total number of trials. 1, 2, 3, 4, 5 trials. So 4 out of 5 trials said that their claim of getting a prize, 1 in 3 boxes, is true. That happened for us 4 times out of 5 trials. That's all you have to do for your probability. There on your worksheet, you're going to conduct this with a partner. You're going to answer this question. So count up your yeses, divide it by your number of trials. And then there's going to ask you a lot of questions about running experiments and how you could use things. And one thing I forgot to do in my other classes is talking about like a coin toss. So if you had something that had a 50% chance, you could use something with 2 sides, right? Heads or tails. So you could flip a coin. If you had a 50% chance, you could still use a dice, but you'd have to think of, well, I've got a 1, 2, 3, 4, 5. I could say, 6. I could say 1, 2, and 3 represent one thing, like maybe this is yes, and maybe this is a no, if you had to do a 50-50. We were going to do cards too, but you guys can't use cards because I can't sanitize them. They're divided into blacks and reds. There's another way to get 50-50. You could even do this. You could do, if you had a 1/3, you could even say, hey, I've got 1 black and 2 reds. This could be a yes or a win, and this could be a loss. But you would have to adjust your deck so that your deck didn't have any any clubs, right? Some of you guys aren't not as familiar with cards, but there's a club. You'd have to take all the clubs out so that you would just have those three, and then you could just do random drawings. So what's going to happen next is Mrs. Koffel is going to pass out a worksheet. I think it looks like she already did. Perfect timing. You guys are going to identify a partner sitting close to you. The reason why is if you move, I have to take a picture and take it to the office so we know who you were around. So let's just keep it simple for all of us. Let's have you work with someone close to you. You're going to choose either dice, a spinner, or colored chips, and you're going to complete this worksheet. When you get to the back page, there's a few questions that it asks you. You're going to answer all of the questions, but don't overcomplicate it. You don't actually need to solve A, B, and C. You're just supposed to write how you would conduct an experiment. So I could say, well, I would use face cards, and I would use the spade and the heart and the diamond. And I would say that the spade represents a win, and these two would be loss. And you could just describe to me like how many trials. I would do 10 trials of pulling a card and recording my results. And so that's what it's asking for, is how you would conduct the experiment. So that's when you get to the backside. When you are finished, give your worksheet to Mrs. Koffel, and you are done with the in-class work. Your homework is the review, and so she'll hand you the review as well, and you can start on your review. So let's go ahead and get going. Look someone next to you, identify who you want to work with, and then one of you can go back and get some materials for your experiment. And I'm going to stop recording now. Let's see.